Okay, sample problems 13.3, 13.4, and 13.5 all deal with a variety of different ways to calculate concentrations. And a sheet that we had in class today, table 13.5 kind of goes through the different ways that we can calculate concentration. Molarity is one that you've seen before, and that's again the mole of solute per liter of solution. So we're going to work through some problems that deal with molality, parts by mass, parts by volume, and mole fraction. And the first couple of these problems are fairly straightforward, just kind of practicing the basic skill of this new way of thinking about concentration. And concentration, again, is just a way to measure the amount of solute in a given amount of either solvent or solution, depending on what you're looking at. So sample problem 13.3 is pretty straightforward, dealing with molality. So it asks what the molality of a solution is by dissolving 32 grams of calcium chloride in 271 grams of water. So again, this one fairly straightforward. We're given just some information, then we need to calculate molality. Some problems that'll get a little bit more challenging later is you actually have to work and interconvert between different concentrations. And so we'll deal with those in problem 13.5. So for this one, what we need to remember is that molality, and we want to write molality with a lowercase m, is the number of moles of solute in kilograms of solvent. And again, how this can get challenging if you're interconverting is if you're given molarity, for example, you're given a volume of solution. And remember, solution is made up of solute plus solvent. So that's a little bit more challenging. So we'll deal with that in 13.5. But this one, again, is just another one of these basic skill problems. Okay, so in this case, we need to find the number of moles of calcium chloride that we have, and we need to find the kilograms of solvent. In this case, the solvent is going to be water. So some of this information is given to us fairly straightforward. We're not given the kilograms of solvent, but we're given 271 grams of water, which is the solvent. Hopefully it's fairly straightforward to remember that that's 0.271 kilograms. Be careful when you're making conversions between grams and kilograms and vice versa. Remember that a kilogram is bigger than a gram. So in multiplying or dividing this by 1,000, we need to make sure that we divide by 1,000 to get a smaller number. And hopefully it'll make sense to you that if you had 271 grams of something and then you converted that to kilograms, that you wouldn't have 271,000. Kind of a good little rule of thumb to remember is that a gram is about the size and mass of a sugar cube. So if you had 271 sugar cubes, you wouldn't have 271,000 kilograms worth of sugar cubes. Okay, so we're given the mass of the solvent fairly directly. We just need to make a little unit conversion. We're not given the moles of solute, though. We're given a mass of that. Well, we know that it's fairly easy to interconvert mass to moles using the molar mass. So 32.0 grams of calcium chloride. And in Gen Chem 2, I generally assume that most people know how to figure out molar masses. So if it is a problem where you're already given what the molecular formula is, I will give you what the molar mass is so that you don't have to worry about that extra calculation. Sometimes, though, it might be important that you actually have to figure out what the molecular formula or the formula unit is. And in that case, it might be something that you do need to go on and work on the molar mass. Okay, so this is 110.98 grams is the molar mass, and 1 mole of calcium chloride. So that gives us 0.288 moles of calcium chloride. So this, again, is going to go in the top there. So the molality of the solution then is going to be 0.288 moles of calcium chloride over 0.271 kilograms of solvent. And that equals 1.06 mole. So make sure again that you have a lowercase m here. Making an uppercase m is going to indicate that you're saying that's 1.06 molar. And that's not the same thing as 1.06 molal. So make sure that you're using the correct lowercase or uppercase letter. And if I can't tell whether it's lowercase or uppercase, you won't get full credit for the problem. So do make sure that it's clearly written with a lowercase m, or you can write molality equals 1.06. Okay, and then it's very clear for me. Again, this is a fairly basic scale problem, just making sure that you take the equation for molality and put in the correct pieces. How the problem could be made a little bit more challenging or a little bit more applied is you may have to do some calculations to figure out the moles of solute that you have. Maybe there's something to do to figure out the mass of the solvent that involves stoichiometry or an equation or something a little bit more involved.